Factor the polynomial completely. So here we have f of x equals x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 28x plus 28. Six-term polynomial, pretty good sized. So I'm looking at this guy, and I'm going to take a look at the possible rational zeros, because that'll help lead to some possible factors. Leading coefficients 1, constant terms 28. So here are the possibles. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, and plus or minus 28. Those are all possible rational zeros. So I'm going to graph the polynomial on the calculator, take a look and see if we can't find a good zero to start with. Okay, so I have the function all entered in the calculator. Go ahead and graph. This is with a standard window. Okay, now it looks like you have a zero here at 1. Let me look at the table just to verify. Yeah, 1, 0. Okay, so let's go back to the graph. And you can see this is a 0 here at 1, so that's going to be a factor. These other two, these could be rational or irrational, not sure. But I'm going to go ahead and get started with that 1 and do some factoring. So I'm going to use synthetic division here. Here are my coefficients: 1, -1, -3, 3, -28, and 28. So I'm saying 1 is a 0. That means I'm factoring out an x minus 1 using this. So this is taking out an x minus 1 factor. Okay, bring down the 1. 1 times 1 is 1, and then add to get 0. 0 times 1 is 0. Add to get -3. -3 times 1 is -3. Add to get 0. 0 times 1 is 0. Add to get -28. -28 times 1 is -28. Add to get 0. Okay, so this is going to be the x to the fourth term. This is x to the third. This is x squared. This is x. And this is going to be the constant terms. And this is the remainder of 0. Now, since there's a remainder of 0, I know for sure that this 1 is a 0 and x minus 1 is a factor. So let me write what's left here. So we have the x minus 1 that's factored out. And we have x to the fourth minus 3x squared minus 28. And that's f of x equals. So now we need to try and factor this trinomial here that has a degree of 4. It looks like it's a quadratic type, so I'm going to apply that procedure. -28. So we have to find the factors of -28 that add to make -3. I'm thinking -7 and +4. Because -7 times 4 is -28, -7 plus 4 is -3. So I'm going to factor this trinomial by grouping. And that's going to be x to the fourth minus 7x squared plus 4x squared minus 28. So we're going to take out an x squared for the first two terms. That's going to be x squared minus 7 inside, plus, and take out the 4 in common, x squared minus 7. Okay, so this factor by grouping looks good here. So let me go ahead and group this. That's going to be x squared plus 4 times x squared minus 7. And that's going to be times x minus 1. Okay, now this is factored among rationals, but it's not completely factored yet. So you have these x squared plus 4 and the x squared minus 7 that both can be factored. Now the x squared plus 4, that can be factored over complex numbers, and the x squared minus 7 can be factored over real numbers. So this x squared plus 4, that's going to factor to make x plus 2i times x minus 2i. And the way I get that is I'm going to do x squared plus 4 equals 0, subtract 4x squared equals negative 4. So square root both sides, x equals plus or minus 2i. So that means x plus or minus 2i equals 0. So those are going to be my two factors, x plus 2i and x minus 2i. Same approach for x squared minus 7. X squared minus 7 equals 0. So x squared equals 7. Square root both sides, x equals plus or minus square root of 7. So x plus or minus square root of 7 equals 0. Well, the x plus square root 7, x minus square root 7, those are going to be my factors. So let me put those here, x plus square root 7, x minus square root 7. And we still need that x minus 1 out in front. Okay, so the polynomial is now completely factored over complex numbers. Okay, so that's how you do it. You have 5 zeros, 5 factors, the degree is 5, so you know it's factored completely. And just remember, when you get to the point where you're factoring over the imaginary numbers, complex numbers, or just the irrationals, use that little trick I showed you up here, where you set the factor equal to 0 and then solve it, and then you kind of take a step back. Once you have x equals plus or minus whatever it is, move that to the other side of the equal sign, and you're going to get your two factors there that will give you the zeros in the polynomial.